Hi, in this video we will discuss some of the concepts of modules and packages in Python. So I'll be sharing my screen. Now the first concept that we'll study or we will see here is modularizing. What do you mean by modularizing? Basically modularizing is breaking your task in subtask. Okay, instead of climbing entire floor at once, you take it as one step at a time. Okay, so breaking your big task into a smaller and manageable subtask. And what we do, we create a subtask of a big task, and later on we combine all the subtasks and form a entire task or project, you can say. So the individual modules can later be clubbed together to build a task. All right, so what are some of the advantages of modularization? First thing is simplicity. Suppose if we are taking an example and you are writing a code, you are writing a function to add two numbers. Okay, so when you are writing it as a function, then you are only thinking about adding two functions, right? As we can see here, you are just thinking about adding two function. You are not thinking about anything else. You are not thinking about taking input from the user, and you are not thinking about displaying output to the user. You are just thinking about adding two numbers. So it basically brings simplicity on the table. Another thing is maintainability, that when we know that there is something wrong with particular functionality, then we know what particular thing we need to edit. Another thing is reusability. The reusability means that instead of writing same piece of code again and again, you just create it one time, and then you just call that particular piece of code whenever it is required. Another thing is scoping. The thing is, whenever we are using a particular functionality, suppose there is a functionality of swapping two numbers, then we use a variable temp, and this is how we swap. Now this particular variable is only required till we are performing this functionality. Once this functionality is done, then we are not using this particular variable. If this is a one big piece of code, then this variable is not going to be deallocated till this entire function is finished, right? And if we are breaking it into smaller functions and we are calling this function from the big code, and then what will happen whenever we will be using this particular temp variable to swap the numbers, and once the swapping is done, once this function is finished, then this particular memory is deallocated, right? And it's a good thing now. Okay, so this was about modularization. Now we will be discussing what are modules. Now modules are the file. Okay, module is the file that is containing that particular code written in Python. Since we are talking about Python, so modules are the files that contain that code, okay, that we have used for modularizing. Okay, so it is a file that contains Python statements and definition. It is also referred to as a script. You must have heard people calling Python scripts, so they are basically modules. And the naming convention for a particular module is something like this: module name .py. .py is the extension that we use to specify a module. And another thing is reusability. Okay, now what we can do, as I just explained, the thing, suppose there is some functionality that we are using very frequently in the code, then instead of rewriting the suppose the functionality is of 10 lines. Okay, so instead of rewriting those 10 lines again and again and again inside the code, we can just write those 10 lines inside a particular module, and we can just refer to it whenever we want. Okay, so it basically ensures reusability. Talking about an example module. So this is a module. We have mod1.py, and inside this we have defined a function, and the function is returning the result of the addition of two numbers. Okay, and this is our Python. This is our current coding file where we are coding, and using this import command we will import that particular module. And when we import a particular module, what the compiler does is it copies all the lines of that module inside that particular code. Okay, so this definition will be copied inside this particular script, and when we call the mod1.add, then it will go to mod1, then add, and then it will return the result. Okay, now the one thing that we need to discuss is when we are using this import mod1 command, what are the locations that our interpreter is going to look for this particular module. So there are three specific places where our interpreter is going to look at for this particular module. First location is the current directory where we have stored the code that we are writing. Another is the Python path, and it is a environmental variable that we set inside our operating system. So that particular path also the interpreter is going to look at. And another location is where we have installed the Python. Okay, the installation dependent default directory, wherever we have installed the Python, the interpreter is going to look at that particular path as well. There are tons of standard modules inside the Python, and they are available at docs.python.org. You can look up. And some of the standard modules that Python uses, for example, the math module, it is when you install Python, that module is automatically installed, and you can find that module in the library directory from at the location where you have installed the Python. Okay, now there are certain ways to import a module. Till now we have seen one way, just using import and the module name. There are certain ways to import a module. The first thing is the simple way, as we just saw, import and the name of the module. And after this, if we import like this and we have to use a particular method, for example the add method that we were using, then we will be using that method using the dot operator, mod1 dot add. Okay, then the arguments that we pass. So we will be using dot operator to access any method or anything, any member of the module. Okay, there is another way to import is you can use aliases. Suppose the name of the module is very large. Okay, there is 50 characters. It's insane amount of characters, but you have 50 characters in the name of the module. So you can import a particular module as alias as well. So basically you are assigning a variable, right? So math as m. So this is the variable which is holding this particular module, and whenever then you need to access a member of this module, you will use m.py, like I have done here. Again the dot operator is being used. Now different way to import is by using the from keyword. How? You are specifying which all members you need, which all particular members you need. Okay, so from math, that is the name of the module, you import these particular methods, these specific method you are importing. And when you are importing the specific method, then you do not have to specify the module name and the dot operator. You can just directly access the members that you have imported. Okay, another thing is you can import everything using the star operator. It will import all the data members except the ones that are starting with underscore. Okay, it will import everything except which is starting with underscore. And the thing is that using this particular command is not a very good programming practice, because practically inside a module there can be thousands of members. Okay, and if you are importing everything inside the code, then it will make your code very bulky, and it is not recommended. And we can use this particular method, this particular command dir.mod1, and it will give you all the function definitions from that particular module. Okay, now what are packages? Till now we have discussed modules. What are packages? Okay, so you can consider packages as folders and files as modules. Okay, so just like a folder can have subfolders and it can also have files, similarly packages can also have sub packages and it can also have modules. Okay, now for a directory, for a folder to become a package, it must contain this file underscore underscore init underscore underscore dot py. This particular file will tell the interpreter that this directory is a package. Now what does this file contain? What is the contents of this particular file? This particular file generally contains the initialization code for that particular package, but the thing is you can also leave it empty. If you are user defining a particular package, then you can just create an empty file with this name, and Python, the interpreter will take everything as default values and your code will work fine. There are some ways to import modules from the packages. Till now we saw how can you import a module. Okay, now we will see if a module is inside a package, then how do you import it. First thing is, again, use a dot operator. You have package, then you have sub package. Basically you are specifying the entire path of that to reach the particular module, and this particular package should be at any of these locations, the current directory or the Python path or the installation dependent default directory. Another way to do it using the from keyword is like this, that you use from, you basically specify the outer path, and when you are importing a particular module, then you use the import, and then if you will be accessing something, then you can simply use this. Right now if you want to access something, then you will have to specify the entire thing, the sub package, then the module, then the add. Okay, you have to specify the entire thing just to add this member, just to access this member. Using the from keyword, basically whatever you specify in the from, you can skip. That is the main line. So whatever you specify inside the from, you can skip. So you can just specify like this, and you can use mod.add, and you can also do it like this, package, sub package and mod, and just import that particular member that you want, and you can use it directly. But this particular way is not recommended, and it is not a good programming practice, because it can it can be a problem with your own add method. If you have a add method inside your code already, then obviously it is going to create problems. Okay, so with this we are done with Python. In the next video we will start data analysis, EDA, exploratory data analysis.